जी फेसबुक पे आ गया लाइव, चलो जी थैंक यू। मियां जियाउद्दीन साहब आ गए हैं, जरा ये ज्वाइन कर लें तो मैं इंशाल्लाह ये शुरू करता हूँ। Bismillahirrahmanirrahim. Assalamu alaikum and good afternoon to all the participants, and salam and greetings to those who are watching us on Facebook. Today PSCE is presenting its technical lecture number 39. Topic is electric vehicles, challenges and opportunities. And today our guest speaker is Dr. Iza Anwar. Before I introduce the speaker, our guest speaker to you, as usual, I have to spell out the rules of the webinar for the convenience of the audience and those watching us on the Facebook. Registered participants for CPD points have to appear live on webcam. However, for the ladies, there is an exception. If they wish, they can cover their face while appearing live on the webcam. During the lecture, microphone of all the participants except that of speaker shall remain in mute position. There will be a question answer session of 20 minutes at the end of the lecture. However, the speaker has permitted questions to be asked during the course of the lecture, but when the question is to be asked, that would be decided by me. When a chunk of questions are gathered, then when the questions accumulate, let's say about 5 to 10 questions, then I will ask one by one to the speaker. This is how she is comfortable. You should make a note that during the lectures, only the questions can be asked by typing the text in the chat box also. But, in the chat box only. However, in the 20 minutes question answer session, you will have the privilege of asking the question using your microphone. Participants on Facebook have a limitation. They can only ask questions through text messages, as we do not have a facility to provide them for asking the question through the microphone. And participants on Facebook should also keep a note that there is a lag of 45 to 60 seconds between the transmission which takes place on Zoom and that goes on the Facebook. Now, this was the introduction. And again, I usually make this request that please keep your webcam on and appear live. Don't force me to make announcements again and again, because this will affect the flow of the speaker and she or he gets disturbed. Thank you very much. I hope today I won't have to make the announcement during the lecture. Now the introduction of the speaker. As I have already told you that today's speaker is Dr. Iza Anwar. She is a devoted professional with 15 years of professional experience in research and academics. Her interests relate to multi-perspective domain of transport engineering, management, and planning. Dr. Anwar has her expertise and interest in three main research areas, which are A, smart travel, smart technologies, smart vehicles. B, disaster and disruption management. C, advanced statistical methods and data fusion under the umbrella of transport engineering. Dr. Anwar, as a specialist, is contributing in national and international policies related to transportation. She is also effectively pursuing cross-disciplinary collaborations and networking, continuous professional development, and exchange of expertise on renowned forums. Today's lecture is unique as compared to our previous lectures. As the name suggests, Dr. Anwar would dilate on prospects, challenges, and opportunities in the use of electric vehicles and its impact on environment, social, uh, technology, and market, and its effect on market will also be discussed. Now, some education details of Dr. Anwar. She did his BSc in Transportation Engineering in 2006 from University of Engineering and Technology, Lahore. And from UET Lahore, she did her master's in Transportation Engineering in 2009. Then she proceeded to Institute of Transport Studies in University of Leeds in UK. She completed her PhD in 2017. She proceeded to University of Leeds in 2012 and completed her PhD in 2017. And during her stay in UK, she has been working on different assignments there also as a tutor and demonstrator for graduate students. And she also worked on some administrative assignments there as subwarden, invigilator, and trip organizer from time to time. She started her career as a lecturer, basically in with the Department of Transportation Engineering, UT Lahore in 2006. And since then, she is there she must have been as a lecturer, then as an assistant professor. So I think she is an assistant professor currently in the Department of Transportation Engineering, UET Lahore. For her PhD, she won the Faculty Development Program Scholarship by HEC. And as I already have told you, that she proceeded to UK in 2012 and completed her PhD in 2017. Dr. Anwar has to her credit around 18 certifications, training courses, attended workshop, and some research work. She is affiliated with Pakistan Engineering Council, Women's Engineers Committee of Pakistan Engineering Council. She's an associate fellow member of Higher Education Academy UK. She's a member of Board of Faculty UET Lahore and a member of Academic Council UET Lahore. To her credit, there are 13 research publications to which she is either an author or a co-author. So this was a very brief introduction of Dr. Sahiba. And now, Dr. Sahib, the floor is yours, and you can continue with your lecture. Thank you.
Thank you for the introduction. And Assalamu alaikum to all of you. I'm sharing my screen here. Please let me know if it is visible to all of you. So as the name suggests,
the screen is shared. We can see it. You can continue, please.
Thank you. So the topic of today's presentation is electric vehicles. I will discuss different prospects, opportunities, and challenges faced by community and the experts. My introduction is already given to you. Thank you. So I will directly take you to the overview of electric vehicles. Before we move further in our today's presentation, I would like you to know that what are electric vehicles, why we needed it, and why so fuzz is created about electric vehicles. Why do we need them? So it started a decade ago that a study came to surface by Hem, Kemper, and Lambrecht. In 2010, they found that the transport sector was responsible for 30% of the final energy consumption of Europe. And out of that 30% of final energy consumption, more than 70% is consumed by the road traffic itself. So it means that these are the vehicles that are creating so much pollution, and those are the that in the end will create lots of energy losses in terms of energy, in terms of money, in terms of health, in terms of deterioration in the environment. This is extremely significant in showing just how toxic carbon dioxide emissions from conventional vehicles are added to our environment. This led to think about the electric vehicles that they thought that will be the ultimate solution to all of these environment related problems. So electrical vehicles, they actually don't have a real engine, but they have a battery instead of that. And actually this battery is composed of series of lithium ion batteries that send energy to the multiple different parts of the vehicle itself, and then the vehicle is propelled based on the on that energy. So there are many types of it. For example, plugged in electric vehicles that can accommodate different drivers' need of the vehicle. The main aspect is that drivers can plug such vehicles into a charging outlet from an off-board electric power source, and that's how this vehicle is charged, and then it can move the way as the conventional vehicles are moving on the road. So if I show you a very simple descriptive picture of it, electric vehicles, they have an outsource where they are plugged in and charged, and then this charger will convert the energy from the outsource, for example, electricity from DC to AC or AC to DC, and it is stored in high voltage battery. Then this from this battery, the control room of that car is entertained, and by the end of the day, the electric motor will rotate, and it will help in rotating the axle assembly, and the wheels will move and the vehicle will propel in the forward direction. Now, what is the significance that they thought that electrical vehicles would provide us? So they thought that electrical vehicles will provide traveling efficiency in terms of time, in terms of energy, in terms of money, in terms of less pollution, comfort, safer to travel, and it will provide energy security. It is affordable and cheaper to run and to maintain. But this is still a question mark. And I will talk about this in the coming slides. Environmentally friendly, because it is assumed that there are zero emissions about them. Less interior noise, less vibrations from powertrain because the operation runs very smooth way compared to the conventional vehicles. Improved braking system, and that is known as regenerative braking system, which means that whatever the power is generated inside it through the braking, when the brakes are applied, some part of this energy is returned to the batteries, and then this power is again utilized in a loop way to get benefit out of it, feeding energy back to the battery from the inertia of the wheels. And this is known as the regenerative braking. It have less pollution or almost no pollution, and renewable energy to charge may reduce greenhouse effects. So these are the main aspects that we think today that we can achieve these aspects if we exchange electrical vehicles instead of usual or conventional or internal combustion engine based vehicles. And also it is eco-friendly because the materials that are used in it will harm less environment. Now, where such vehicles are suitable, the questions arise that where these vehicles are usable. Do we need to use all sort of vehicles? Do we need to switch totally on electric vehicles? And shouldn't we use any other conventional vehicle? Will they be suitable for shorter distances or for longer distances? What are the reasons that we should use them? And how batteries are charged? What if the batteries are exhausted, and what would be the life cycle effect of these batteries? So before answering these questions, I would take you to different types of electric vehicles that we have in here. There are three broader types of electric vehicles, and they are classified based on the degree of electricity that is used as an energy source. So we have all electric vehicles that only runs on electricity. we have plug-in hybrid electric vehicles, and then we have hybrid electric vehicles. Electrical vehicles, their chargers are classified according to the speed with which they recharge an electric vehicles. So one of the important aspect is charger of these electric vehicles. Um, I will discuss this in detail in the coming slide. To give you an overview, there are three basic types of electric vehicles. All electric vehicles, they involve battery electric vehicles and fuel cell electric vehicles. Then we have plug-in hybrid electric vehicles and hybrid electric vehicles. So this diagram will show you exactly what we mean by these different types of electric vehicles. For example, right now most of us are using conventional vehicles. So the first column shows you that its energy source of energy is fuel, fossil fuel, diesel, petrol, and the energy that is transmitted to the vehicle for its movement is based on the consumption of this fossil fuel, and by the result of that we have emissions that is polluting our environment. Then we come to the hybrid electric vehicles, in which the source of energy is again fossil fuel only, but for energy consumption we have fuel, burning of fuel, as well as we have battery that will store some of the energy, and as its result the emission is lesser compared to the conventional vehicle. Now talk about
Dr.
plug-in
Anwar,
hybrid vehicles. Yes,
Dr. Anwar, I'm sorry, I
yes,
have to make one announcement.
yes.
Yeah. Gentlemen, please switch on your cameras who have not. It doesn't look good that I will take names of those on this forum, those who are not adhering with the rules of this webinar. You have to keep your webcams open and you have to appear live. Those who have not, please do it now. And this is the first and the last announcement I'm making. Thank you. Go ahead, Dr. Anwar.
Thank you. The third one is plug-in hybrid, in which we are using both of the sources. We are directly charging the battery, and the other source that is working in parallel to that charging of the battery is the conventional fossil fuel source. And likewise, the consumption is based on two things. First is directly from the fossil fuel, and the second one is from the battery that we have charged from an outside source. But here, a major chunk of the energy is drawn from the source of that we are getting from the directly charging rather than on the fossil fuel, and as a result the emission is very low compared to the other two sources. Now the last one, all electric vehicles, they are totally electric vehicles dependent on electricity, and there is no fossil fuel involved in it. Consumption is through the battery that we have charged from an outer source, and as a result there is no emission. So I will initiate a question in your minds, that will there be no emission at all? So can we say that if we are using electric vehicle, then our environment is like 100% pollution free? So I leave this question here and I will address it by the later part of my presentation. But by then, I want you to please stimulate your mind to think that will there be no emission at all? Again, I would like to show you that what I have just talked, you can see in
Dr. Saab, we cannot hear you. Riaz, can you hear my voice, please? Rizwan Mirza, can you hear me?
Yes, I can.
Yes, yes, Sahir, we can hear you.
Okay, Dr. Saab, I think the problem is at your end. You will have to check your your internet. Yeah, you can disconnect and come back again. Okay, that's good. I think the speaker has disconnected herself and she will be connecting herself again. So let's wait for that time that she comes back and starts her lecture again. Yeah, she is back, Alhamdulillah, and hopefully she will restart the lecture again. Dr. Saiba, you can resume from where you got disconnected. Thank you. You are still in an unmute position. You can unmute you are in a mute
Right.
position.
Thank
Yeah,
you.
thank you.
I
Thank
got
you.
it. I got it. Thank you. So, as I told you, we are done with this slide. I think we were talking about this one. So next, I will take you to the charging aspects, and there are three different charging aspects that we need to consider. There are three different types of chargings, and level 1 charging, level 2 charging, and level 3 charging. So EV level 1 charging, electric vehicles charging uses a standard household outlet. So if any one of us want to charge our vehicle, we will have it in our household, and we can charge with 120 volt and is plugged into the electric vehicle directly from the socket. And it takes around 8 hours to charge an electric vehicles from approximately 75 to 80 miles. If we charge it for 8 hours, our vehicle will run for 75 to 80 miles. Level 1 charging is done at home or at our workplace. So it is assumed that it is accessible to all of us. Level 1 chargers have the capability to charge most of the electric vehicles on the market. So all the electric vehicles that are available in the market, we can charge with this one. Then level 2 charging, it requires a specialized station to provide 240 volt. And this is compared to the previous one, a more commercialized version of it. So we can have it at our home or at our workplace, or especially at the public places. For example, where there are lots of motorcycles, they are standing somewhere. If there are electric motorcycles, then we can plug them in there. Or if we have vehicles that are standing in a parking lot, this is that kind of charging that we can use in the public stations. And it takes around 4 hours to charge a battery that can run 75 to 80 miles of range. Then we have level 3 charging. It is more commercialized version of charging, fast charging, currently the fastest charging station in the electric vehicle market. And DC fast chargers are used and are found at dedicated electric vehicle charging stations, and they charge a battery up to 90 miles of range in approximately 30 minutes. For example, if we are moving in a big bus or truck or etc., electrically operated, then we can charge them for 30 minutes and it can take us to approximately 90 miles of range. Now, so far the picture is quite rosy, and we think that all of us should go to buy electric vehicle right now because there are so much advantages of it. But there might be negative aspects of this. For example, as I just asked in my previous slide, that do you think that it is affordable to all of us? Are we ignoring any aspect when we talk about that the electric vehicle will cost this much and we are charging it. It's very easy in operation. Should we go for it? Would we be able to afford that? For example, range of Nissan Leaf is approximately 180 miles, but we have to plug in it somewhere where we can charge it. Also, it is said that it have high ranges, but when the vehicles were tested, for example, this Nissan Leaf was tested, it did not give us that range that it was expected. And what we assume right now is that we are assuming it that it is going to run and will have very minimum stops. Tesla cars, they just go far and not further. So when Tesla car, it was tested, it didn't promised all of the aspects that we were expecting at that time, and its battery exhausted quite earlier than the time that we were expecting. A separate charging unit or infrastructure is required to be installed to power these vehicles. So we have a limitation. For example, let's say if Lahore is going to have lots of electric vehicles and we want to travel to some other city where there are no electric vehicles right now and their infrastructure is not installed there, then how we are going to charge our vehicle there? So these kind of aspects we still need to think about. There are three main things we need to consider. I just told you about the levels. So all the options for electric vehicles supply have three main points of considerations. For example, first one is level, describes the power output of an electric vehicle supply energy outlet. And then the types refers to the sockets and the connectors used for the charging. Then we need to consider the mode that describes the communication protocol between the vehicle and the charger. So if you see these pictures on the very left side, we have four different modes. And first one is household socket, and we can see that it's the simplest of all. And its usability is for small motorcycles, electric bikes, and the vehicle is connected through the standard 3-pin socket. The charger in the vehicle converts AC to DC and then controls the battery charging. It allows maximum of 11 ampere. The mode 2, it is actually non-dedicated socket device. So it have an adapter that will work as a communication between the socket and the energy source. So transitional solution before mode 3 was mainstreamed. So it lasted for some time. Then came the mode 3. It's fixed. It entertains a larger variation of electric vehicles for charging. Recommended day-to-day AC charging method, and it is connected to the electrical network through specific socket, plug-in, and dedicated circuit. So maximum power output is 7.4 kilowatt in a single phase and 22 kilowatt in 3-phase. Last one you can see, it's mode 4 and DC connection. It have a converter, then a DC connection. For example, Shedemo connector. This company is doing really good in terms of providing connectors and the infrastructure. So usability is that it's used for the commercial fast charging station and will not be accessible to common man. It's just for when we have to charge fleet. Charging done in DC through an off-board charger, allowing the system to withstand high power. Maximum power output is 50 kilowatt for Shetimo and 120 kilowatt for Tesla, 350 for CCS. Now, I would like to talk about EV manufacturing and the market. So if you see the world share, we can see that China is taking a lead. They have 45% of market share for the electric vehicles. And then following to that is Europe, then the United States with 22%, and then the rest of the world with the 9%. So if I show you that global electric car sales from 2013 to 2018, we can see that this green part, darker green part, shows that this is battery electric vehicles. It means that all of the energy sources of battery. no fuel sources there. So we can see that China is doing a great deal compared to the other countries, Europe, United States, and then the other countries. So it is taking a lead. Then comes the Norway, and Norway, following to Norway, um, we have Germany and Netherlands. So and as well as France. So they are taking and Korea, especially the South Korea, they are taking lead in these markets, and they are capturing most of the markets regarding electric vehicles, new electric vehicles, and their sales. Why do we need electric vehicles? What would be the fuzz? What we will improve with these this kind of into that, we should understand the concept of smart city. We talk about smart cities, but what does it exactly mean? So by smart city we mean where people have good health and well-being, where there we have smart living, we have smart governors. That means that user people friendly, environment friendly policies, where we have smart economy. It means that we are not spending extra money on health or environment or any other aspect, but all the public focused policies are there. And then we have to improve our environment. Smart environment and transportation, smart transportation is playing a big deal of a big part in creating a smart city. Smart transportation means that there shouldn't be any pollution or minimum emissions, and it should provide services to all sectors of your society. From a transportation engineering perspective, urban mobility is prime most important thing in any city's economy, or if any country want to grow economically, they should have urban mobility indicators to be met. For example, they should have affordable public transport, uh, other modes accessible to all parts of the country, less air pollutants, less air noise, almost no road deaths, access to all kind of services, less or minimum emission greenhouse emissions, and should meet the climate change goals. Congestions and delays, minimum energy efficiency, opportunity for active modes of mobility, multimodal integration. We are not depending on the car, but we are depending on the public transport and other active mobilities and spending less money on the vehicles. Then satisfaction of people with the public transport, traffic safety, active modes, quality of public spaces, urban functional diversity, community travel time minimum, mobility space usage should be efficient, and lots of security. Uh, so with these electric vehicles, it is assumed that when it is calculated, it shows that approximately out of these 18 different indicators, approximately more than 30% are achieved if we will switch to battery electric vehicles. We talk about sustainable development goals, and if we see closely, directly with these electric vehicles in our society, we can hit good health and well-being. We can meet the goal of affordable and clean energy. We can meet the goal of industry, innovation, and infrastructure, sustainable cities and communities, and climate action, as well as peace, justice, and strong institutions. Also, it will enhance the partnership for these goals with other countries, other nations, and at multiple tiers. It is important to understand the supply chain phenomena of conventional vehicle with respect to electric vehicles. So what is happening with the conventional vehicle? All the different supply chain, for example, elements, supply chain elements, for example, automotive parts suppliers, automotive component suppliers, automotive original equipment manufacturers, they are already established and they are in good communication with each other. Their cooperation with each other is going really well. But what is happening with the supply chain of electric vehicles? As it's not an established industry right now, and it is still going through lots of phases of development. We can see that most important part in electric vehicle is the battery. So for that we need to have materials, cell components and electronics, lithium ion battery cell packs and players, automotive part component suppliers, and automotive original equipment manufacturers. So all of these are not in collaboration with each other efficiently as it should be. So it is still establishing their supply chain of electric vehicles is yet not defined compared to the supply chain of conventional vehicles. So this is another description that will make this point more clear to you guys, that for example, in case of electric vehicles, we have already established components of these suppliers. We have automakers, we have affiliated dealers, and the market where people are going to buy these facilities, these vehicles. It is already established, and there are no doubts regarding this in our society as well. But compared to that, we have electric vehicles, and it's still going through the phase of research and development. The parts are prepared in some other countries, it is assembled in another country, it is supplied to other countries, and the sales where these electric vehicles are going to be distributed and merged in the society, in the countries, is also yet not defined clearly. It is initiated by various players, specializations, people or different countries. They are doing independent research companies. For example, someone is working on the battery, someone is working on the material, someone is on the assembly, and they are not yet fully coordinated with each other. Then comes independent suppliers, battery motors, inventors, suppliers, etc. Then there are different automakers, then there are independent multi-brand dealers, and the end user, that is us people, we are still scattered and we have many doubts about it. So compared to that, conventional vehicles, the market of the whole, you can say, the value chain is yet not defined and yet not clear compared to the conventional vehicles. Ideally, there are various stakeholders in electric vehicle industries. I would like to start it, though it works in a loop, the electric vehicle ecosystem, it works in a loop, but I would like to start from the government. Let's say any country, if its government is fully committed to meet the goals of environment and all other aspects that we have just said, and is considering that through the use of electric vehicles they can take care of, they can snub the challenges that are faced by them through conventional vehicles, and the solution.
Dr. We have two questions.
Sorry, yes, please.
Yeah, Dr. Anwar, we have two questions. One
Yes,
is from Ijaz Ali. He's
Yes.
asking, while keeping in mind the power load shedding issue in our country, is there any chance in future to convert these vehicles to solar vehicles?
I would say that the chunk of material relating to this question is coming in coming slides, later part of the slide, and where I'm talking about different energy sources. So I will request them to please bear with me, and I'm going there in a while.
Okay, the second question also relates to the second part, so I will keep it on hold. You can carry on with your lectures. Thank you.
Right, thank you. So it depends on the will of the government. Then government have to decide or design certain regulations that should support different policies, starting from the very first point from scratch. For example, getting a hold on the materials that are used to make batteries, then assembling the parts, and etc. So regulatory authorities and regulatory legislations, they are required to be formed in place. Then comes the power utility. For example, like you just said, that what would be the power sources for that. So this kind of issues need to be resolved, that either you are only relying on fossil fuels, the conventional resources, or you want to use a mix of energy resources for that. For example, solar power, wind power, hydrology, hydraulic power, etc. Then comes the infrastructure providers, because you are going to get into a new field where you don't have an infrastructure and you have to install infrastructure from very scratch. So you need to have infrastructure providers in your hand. To do that, you need to have funding agencies and different sources related to that. Then the consumers, the dealers, automotive manufacturers, original vehicle manufacturers. So all these kind of different kind of stakeholders, they should work in collaboration under the umbrella of each country, so that they can communicate with not only internal strategy of a country, but they should collaborate with other nations as well, because it's not one country's job. Then I come to this point where I can show you this diagram, and you can see that the government policies that I just talked about should deal vendors, original equipment manufacturers, then distributors, consumers, as we are engineers, so whatever we do, it sure have, and this is what we are ignoring in consider the infrastructure, distributional companies, and financial institution. And by the end of the day, when we are talking about electric vehicles, we also need to think about that whether it is going to affect the environment at later stage or not. So battery electric vehicle value chain framework, it involves a broader spectrum of all the activities and services that are required to take a product from its conception to in the end market. So it's not just a thing that we bring an electric vehicle, we started charging.
Dr. Saiba, I think we are having a problem with your voice. It's not coming in. So maybe the internet at your end is not working well. So, oh, okay, she got disconnected. I think she'll come back soon. Riaz or Rizwan, to be sure that there is no problem at our end, just let me know that I am audible.
Yes, you are very much audible, Tahir.
Okay, thank you. Thank you. I think there is an internet problem all over the network, though, I mean, it's working well at our end, but still normal speed, which we usually get, is not we are getting today. So, and I have two backups for the internet, that is from the Zong and from PTCL. The speed of both are not as they used to be. So maybe it's an overall issue. So what do you think, Rizwan? Should I ask when she comes back? Should I ask Dr. Saiba to switch off her cam. Maybe that will improve the communication, I think.
Yes, I think if there is a problem with reduced bandwidth, it will improve. But how will she communicate then?
Well, the screen, her screen would be on the monitor, and she can talk without showing her face, so she should be okay.
Apologies, I'm not sure why it is happening this way.
Dr. Saiba, you can try by switching off your camera.
Camera?
This might give you a better
Right.
speed. That
Right.
might give you a better speed. When there is a question answer, then you can switch on your camera. But
Right.
in the course of the lecture, please keep it switch off.
Thank you. Thank you. Okay, so we compared different types of materials that are used in the battery, and based on the safety, cost, energy density, cycle life, and nickel content in those batteries. So that's how we compared it, and we found that mostly the lithium cobalt dioxide batteries that are mostly applied to the consumers, they have low cost. So if you see the cost of that, then it have low cost, and one can go consumer electronics, but increasing application of X series of EVs, and it have high energy density. And when we say that we have high energy density, it means that it also give us speed efficiency and time efficiency in terms of that. See that 2 of energy density, and it means that it also shows the high energy density, and it means that this kind of battery is really good if you are looking for the energy density. There are two different things. For example, the third one, LMO and LFP, lithium dimanganese tetraoxygen, and then the lithium iron the lithium iron phosphorus tetroxide. Both of the energy, and we have achieved high, in fact, very high safety levels and cycle life. And which shows that this battery, though its cost is very high, and it shows lots of safety efficiency as well. So electric vehicles and fuel cell electric vehicles based on their energy. So if you see that vehicle types with energy sources, lithium ion battery based on the natural gas, that is based on natural gas, and the one that is based on solar and wind energy is more fuel consumption is there, more fuel efficient. So we can see that if we have a source behind this lithium ion battery as a solar or wind energy, we have better energy consumption emission. If you see, if you take the case of hydrogen fuel cell electric vehicles, then we can see that either we have we are using natural gas or wind energy, the fuel energy consumption is almost same. There is a point no emissions or less emissions. For example, 2.99 emission in case of wind energy, or hydrogen fuel cell. Arises in your mind that why hydrogen fuel cell electric vehicle, where the energy is going and why there is a difference in that. I show you this picture where we can see that in hydrogen car compared to pure electric vehicle, lots of energy is wasted in here. For example, at the process of electrolysis, compression, liquefaction, transport and filling, and fuel cell and power generation. So this element causes lots of energy loss compared to the one that we have pure electric vehicles. So globally, the future is of lithium-ion battery pack market, and it is more efficient. Its price is reducing. The market sale of lithium-ion battery, you can see until 2020, its market share is increased a lot. So if I show you these three diagrams, it is easy to see that with the passage of time, there is there is a reduction in the cost of the pack cost of the lithium batteries. It is reducing from 2015 to 2025. We'll see a huge loss in the pack cost, so it will be quite affordable. And the same applies to the other elements in case of lithium ion battery. In third world countries, depending on the size of the car, for example, small, medium, and large, for battery electric vehicles and fuel cell electric vehicle and plugged-in hybrid electric vehicle, we can see that for smaller cars, battery electric vehicles are more efficient and reliable. Most useful according to their practicability, reason related to the battery size and cost compared to the other two types. For the medium as well, it is more better to use battery electric vehicles in terms of PHEV and FCV. But in the large vehicles, we still have lots of challenges. For example, high cost and limited range. So we need to think about that. Now come to the policy and practice. So electric vehicles in the context of Pakistan, and discuss opportunities, challenges that we follow. For example, we need to think that are people aware of electric vehicles and its background feature, or do they think that whenever we get electric vehicle, all problems will be solved? Are people willing to adopt electric vehicles? Can urban development that is existing right now will accommodate electric vehicles? Do we have sufficient and enough infrastructure for that? Can future development accommodate electric vehicles? Are we moving in the right direction? So these are the questions we need to ask from ourselves before going into this aspect. How to integrate all of these systems together, because we will be going in a transition phase rather than having 100% of electric vehicles. Before that, we need to go through a transition. What are the main hurdles and the challenges that are faced by Pakistan to entrain EVs? And what are authorities and institutions they can what they can do to adopt EVs? How EVs will affect the land use and the infrastructures and the markets? And I also would like you to initiate your mind that why we went for electric vehicles. So out of many reasons, there were two main reasons that make us to opt for electric vehicles. One is increased greenhouse gases emissions and air pollution and the climate change challenges, and the other one is to overcome the energy crisis caused by the depletion of the fossil fuels, because fossil fuels are going to be exhausted in not that far future. For example, if you see 10 to 15 years back, we all in our country we were shifting towards CNGs. So we were thinking that we shifting on the gas will be ultimate solution to everything. But what happened? That resource was exhausted very soon. So we need to think different aspects. Now, the environmental impact aspects of electric vehicle is that in China, according to their Vehicle Environmental Management Annual Report 2018, the vehicle emissions contributed 52.1% of particulate matter in Shenzhen, China, and that followed by the Beijing that had 45% of it. And there were almost 6.5 million premature deaths that is happening every year due to the poor air quality, and around 3 million people died from exposure to all outdoor air pollution. Vehicle emissions are one of the three main leading factors to cause outdoor pollution. Global warming, which is caused by greenhouse gases emissions, it is dominated by 90% of carbon dioxide and is affecting people's life, and this is most part of it is due to transport sector. There is an heated argument among the researcher is that the production of electricity for charging the battery electric vehicle or the generation of hydrogen for fuel cell electric vehicle can produce great deal of greenhouse gases, because the source that we are using behind these battery electric vehicles is either fossil fuel or the hydraulic or wind or solar energy. So what kind of energy source we are using behind these electric vehicles will define that whether it is a viable or doable or emission free solution or not, or are we shifting its problem to another place. For example, if we say that electric vehicles are going to provide us with zero emission, then what kind of source for that we are using? If we are still using fossil fuels behind that, then it means that we are wrong. We are not totally 100% emission free. Now, it depends on the primary source to generate the electricity: solar power, wind, nuclear, or hydropower. With solar electrolysis hydrogen, the greenhouse emission of fuel cell electric vehicles can be reduced up to 99.2% comparison to internal combustion electric vehicles. BEVs can completely outperform ICEVs in the reduction of greenhouse emissions with the development of right technologies and policies. Now, if you see the literature about electric vehicles, we can see it is either focusing more on economy, uh, and you can find many studies related to discrete choice analysis, or the other aspect is psychological aspect, and these are mainly the factors to adopt EVs in our culture. So as a result of these studies, the approach towards the adoption of EV is from two perspectives. First, many governments or car manufacturers, they aim to increase electric vehicle adoption by improving electric vehicle attributes and supporting system, and by incorporating the factors and the theories from psychological studies. For example, user and perspective. For its utility, we can see from here that how different attributes, financial attributes, technical attributes, policy attributes, and infrastructure attributes are contributing in the utilities of battery electric vehicle, plugged-in hybrid electric vehicle, and the conventional vehicle. And from an individual point of view, socioeconomic characteristics, for example, will our pocket will allow us to buy those electric vehicle. Psychological factor, for example, if like we have many questions in our country, like if we sit in electric vehicle and if there is a rain or if there is a flood, will we get a current electric shock or not? Spatial factor, experience with EV, social influence, mobility car oriented conditions, etc. Sustainable battery electric vehicles, it's a multi-pronged strategy that should engage consumers, suppliers, and distributors, but not the end users. Right now, we are just focusing on the end user. So it will be sustainable if we will see it from a broader perspective. It will be more economical, environmental friendly, and social friendly. In a city which we call as a smart city, we can see that the electric vehicle infrastructure and public safety would be the prime most important thing. And this is what we can achieve through multimodal intelligent transportation system, and electric vehicles is the main aspect of that. And when we say electric vehicles, it doesn't mean just the cars, but the electric vehicles, electric scooters, electric trucks, and all of those vehicles that are in our use. Now, how developed world is switching towards the smart city? What are the policies, or what are the footsteps that they followed? And we still need to think about it. They planned ahead of time. They realized that what is wrong, and they realized it that, and then they took steps regarding this. For example, they took it very serious. At parliament level, then regional and local authorities, they all sat together and they cleared their mind on the line of action. Compared to that, in Pakistan, if I say, we don't have any national transport policy. So they have their national transport policy, and that's where they are very much clear about their goals. Then they included all stakeholders. They sat together and they talked about it, including the underprivileged people. They integrated technology led energy efficient vehicles, all of the vehicles, they integrated them, and then they decided that all of them should be electric vehicles. Safe, accessible, and affordable transport for all. The most important thing they did was they decoupled economic growth from the fuel resources. They stopped relying on the fossil fuels, but they went for multiple energy resources. For example, wind energy, solar energy, and uh, hydraulic energy, as well as the nuclear energy. They made road safety as their prime importance, reduced negative impacts of noise and air pollution, and then they went for multiple fuel resources. About the challenges and opportunities that we face today are regarding production of electric vehicles, their social impacts, their economical challenges, geopolitical challenges, environmental challenges, and technological challenges. Talking about production challenges, and I consider it's the most challenging aspect right now. The development of new major industrial sector is going to take place through these battery electric vehicles, and they are predictable, has consequences for the relevant raw material and the supply chains. Transition to electric motors and batteries are the main component of the powertrain. So when we talk about electric vehicles, if we consider the main important thing is about the electric motor and the batteries. Major structural changes in the raw material used in the automotive sector. So what we have, no country have all the resources, have under investment in production capacity, long lead times. So not all the countries have all the resources, they have all the targets, skills, and experts in them. So what is required for a battery production is that increased demand of new material. For example, if nickel is important or cobalt is important for this, not all the countries, those who think that they should make battery electric vehicles, they cannot, because not all the materials that are needed to make an electric vehicle in their country. So they need to require that raw material from some other countries. For example, aluminium, graphite, lithium, copper, nickel, cobalt, etc. So there are critical material in many countries, and with these critical materials, there are critical issues. For example, different countries have different materials. Sustainability of material supply chain is difficult to ensure because of the lack of identification and traceability of each stakeholder along the material value chain, from the mine to the very end product manufacturers, and that is the case with the electric vehicles. The international nature and diversity of local regulations and minimum reporting standards blur the overall view of the value chain. So each country have their own rules and regulations, and some countries are so ethically strong that they don't want to go into conflicts or risk or anything that they think is against the law or breaching of the law, they don't go through those channels to get that. The limited information or product manufacturers and their customers that result from these gaps in. For example, for instance, an electric vehicle holds about 5 times more copper than an equivalent ICE vehicle, and it is found in electric motors, battery, and wiring. And large quantities of copper is required for upgrading the power grid and extending infrastructure for EV charging. But it is not available to all of the countries. Cobalt is imported from Congo, where it is illegal to export cobalt. So this is very important to consider these aspects, that how to get hold on those raw materials. The challenge can be overcome by an increased responsiveness to raw material supply, by ensuring that the supply chains are traceable and transparent, and by developing mandatory regulatory framework among different stakeholders and among different nations. Social challenges involve mass battery electric vehicle adoption and production that requires diverse strategies that impact the welfare of the people locally, regionally, nationally, and even transnationally. And it is required to advance the development of EVs. For example, investment in the infrastructure, in building the knowledge, in making people aware of these different changes. Then comes the economic challenges. EV purchase prices are not yet competitive with ICE vehicles, and governments are juggling with different combinations of supply and demand side incentives, import and export options, production policies, and standards, while ensuring demand and supply balance whilst addressing the potential supply disruptions and demand fluctuations. Also, the implication of tax revenues are very important to consider, especially the growing uptake of EVs may alter the tax revenue derived from vehicle and fuel taxes. So when it was happening for case of Pakistan, there was a comparison done. It is you may say it is in its very initial phase, when it was estimated that the cost of vehicles based on their petrol, for example, Wits, Swift, and Cultus, it went up to like 1 lakh 50,000, 20 lakh, 19 lakh. But when it came to electric vehicles, we saw that it was estimated as 18 lakhs or 21 lakhs. Then it was estimated that if it have a full tank or full charge in cost of Pakistani rupees, we found that electric vehicles more economical. Then it was estimated over a month, over a year, over 7 year, over maintenance cost, and then the maintenance cost, fuel, electricity cost, and the car cost. And by the end of that, we saw that the electric vehicles were found more economical solution compared to those vehicles that were on fossil fuel resources. But what it gave us a rosy picture about without considering the basic source that was behind these, the basic fuel source, the energy source. For example, the fossil fuel, hydraulic, or wind or solar energy. Geopolitical challenges involve supplies of raw materials that are exceedingly reliant on national policies and strategies, and their supply is often exacerbated in cases of geographical concentration of extraction or refining. Examples require ores extracted. For example, many countries have ores of specific raw materials, and they don't fancy to give it to other countries without going through proper regulations. Then comes the environmental challenges. For example, if we are using battery electric vehicles, how it is going to impact on the local ecosystem, and what would be the life cycle emission analysis. We need to consider this important aspect, because in the life cycle emission analysis we can judge clearly that either it is a viable zero emission or emission free source or not. EV manufacturing and adoption should aim to maximize the greenhouse gases emission reduction benefits, and to achieve these policies aiming to support the acceptance and adoption of EVs must be combined with measures that are calculated to decarbonize the electricity generation. Furthermore, the battery end of life management, like when the battery would be exhausted, where we are going to discard it, either whether it will affect the environment or not, or how we have to make our environment sustainable and safe with the after effects or the negative impacts of that battery residue. So there are many risks that are associated with it that we need to consider. Then comes the technological challenges, for example, charging infrastructure, high capacity DC charging stations for installation, manufacturing and assembly, battery size, whether its size is bigger or not, because we know that bigger prices are related to the increased charge time. And but if we have a high density battery, then it will give us high range of travel. And if we have a high density battery, then it means it have a more cost and its size will be bigger. And on the other hand, if its size is bigger, then it means that its weight is bigger and it will affect the mileage ultimately. So it's a very tricky combination that we need to consider as a technological challenge. For example, if I compare Tesla with other companies, then I can show you that the very first car that hit the road, it had a lead acid battery, so it didn't give those aspects. It didn't meet those promises that it made with the audience. If I show you this comparison with Tesla, Jaguar, and Audi, and we can simply see that uh, despite having all the yes for the Tesla, it didn't give us high voltage battery kilowatt per hour. It didn't give us that power that we required. And other vehicles failed in that, but Tesla failed in providing high voltage battery. And same is the case in here. It couldn't meet the targets of high voltage battery, and but it gave maximum battery deflection and maximum published range. Range was good, and but it lagged many. All of these, if you can see all of these, they didn't whatever they promised, they couldn't meet their goals, because it's a very tricky thing, and mostly the technological aspects and the challenges were the reason that couldn't meet the targets. But still, Tesla is doing great, and it is still improving its technology. If I show you the major challenges from the demand side and from the supply side, then we can see that the main barriers from the demand side is that people cannot afford high cost, and there is limited infrastructure, and towards the advantages of electric vehicles, consumers have skepticism. So all of these challenges, though they have their prospect solutions, but there are still challenges, barriers to overcome right now. And from the supply side, they have lack of supply chain development that I have explained in my earlier slides clearly, that we don't have identified institutions at many levels. And then the collaboration among them is very difficult. Then the grid optimization and all that, though we have prospect solutions, but there are still challenges that we are facing. So by the end of the day, who is going to win the race? So we know that electric vehicles will do really good in terms of many things, but it is very difficult it's a very complicated assembly to make. So any country that will have these expertise or the factory or the expert people that can assemble it in a single assembly, rather than importing one part from another country, assembly from another country, and all those aspects, the country who will be sufficient in doing assembling all the parts together will be in benefit. The technology, that as an expert, as an expert, I can say that if the technology they have in their country to assemble all those parts, or if it get any fault in that, if they are If they will have that expertise to do that, then they will be in benefit. Also, those countries that have the raw material within their own country will be the pure beneficiary of this. And by the end of the day, they need to provide the infrastructure. And if they have sufficient funds for that, then the battery electric vehicles is a real charm for them. About the energy management system, so it is important because it plays a crucial role in energy system with multiple energy sources, because they control the power flow in the powertrain and can determine the vehicle performance, efficiency, as well as the life expectancy. So there is extensive research on it. I will quickly skim through a couple of slides because I put these slides for those people who really want to do research in this regard. So there is less work and limited research done on energy management strategies for plugged-in electric vehicles, but there's lots of work that has been done for hybrid electric vehicles. This energy management system, they have both forms to do that, optimization based and the rule based, and lots of work is already done about this. There are many pros and cons for this. So those who want to do research in it, they can do for case of plugged-in electric vehicles, because they have only used fuzzy logic based supervisory for the battery powered vehicles, but there's still lots to do about the future considerations, about how the is energy management system, what should be their algorithms, how what should be the methods that they can use further to enhance the PEV energy management system. So this is really something to look about it. Then it comes the mass electric vehicles. And as I just told you that when we say electric vehicles, we are not just talking about cars, but trucks, motorbikes, bikes, buses, and other mass transit. So if I show you how China addressed this mass transit issue, so they developed their automobile system. They developed their automobile sector. They gave tax exemptions. Their policies were really focused on research and development. And then they particularly focused on the charging infrastructure. They aggressively installed charging stations, and they gave they gave incentives related to that. Government was very much involved in it. So their policy and guidelines were really, really sportive and were very clear about it. Then the consumer adoption, they made sure that whatever they have initiated, the end user should get benefit and should get whatever they have planned for them. So it happened from the very start, development of auto sector, charging infrastructure, government pushed their policies with a clear mind, and then the consumers by the end of the day adopted whatever they said. They did a good SWOT analysis in which they considered their strengths, like no pipe tail emissions, better tank to wheel efficiency, reduced noise pollution, and less maintenance. And they also considered their weaknesses. For example, the high cost of batteries. So they gave lots of incentives regarding this. Range concerns, they worked through this through research and development. And the requirement for the charging infrastructure that I just told you, that they installed it rigorously. They had opportunities. They could reduce the oil consumption, reduction in emission, and meeting the sustainable development targets. And they also had some threats. For example, electricity shortage. So how they managed to overcome this shortage? They went for multiple fuel resources, energy resources. Then improper and insufficient charging infrastructure and political stability. So they made sure that these two aspects should also be addressed, and it was addressed. So I show you what are the commitments regarding electric vehicles in SAARC countries. So if I take you to Afghanistan, it aims to cut emission by 13.6% from business as usual by 2030. And their source is that they are relying on the international support. If I show you the example of Bangladesh, Bhutan, India, Maldives, Nepal, then you can see that they have their own targets to meet, but they are relying on their own business, on their multiple resources like transport industry and sector, and they have their own funding resources as well. Compared to that, Sri Lanka, Pakistan, and Afghanistan, they are relying on international grants. For example, if I read about the Pakistan, you can see they intend to reduce to 20% of the emissions by 2030. They want that greenhouse gases should be reduced to 20%, but this is subjected to the availability of international grants. So if we have international grants, then we will be able to do that. Otherwise, we still need to think, because it is estimated up to 40 billion USDs. Electric cars in Pakistan, the very first policy that we have was in November 2019. And based on that policies, it was a solution to present and the impeding problems relating to transportation, environment, economy, and power. So if I show you where we are standing right now, the qualitative assessment of readiness, it means that how ready we are. So we are ready to somewhat with two-wheelers and three-wheelers, and some of the body parts we are making in here. Control system, we have cables and all that, but the major chunk regarding four-wheelers, heavy and light vehicles, we are not ready yet. So lots of work to do right now. It is estimated that despite of all transmissions and distribution losses, almost 500,000 electric vehicles can be fully charged daily with a supply of just 1,000 megawatts. Due to efficiency of battery-based energy storage, electric vehicles can give the same mileage with 1/3 of the cost compared to fossil fuel rivals. This policy also says that due to this efficiency, even if electric vehicles are charged with fossil fuel-based electricity generation sources, such as natural gas or coal, almost 25 to 40% of fuel can be saved due to higher electricity generation efficiency of larger units. This directly translates to a lower import bill, and electric vehicles require minimum maintenance, so does not need oil or other lubricant changes, which further reduces imported oil requirements. The efficiency of electric vehicles results in 70 to 80% less environmental emissions. So if you do a comparison, this policy tells us that emissions 1.47 billion kilogram per year of carbon will be avoided. Fuel savings 0.68 billion liters per year compared to fuel consumption. And if you see both of these figures, they are nearly more than or nearly half of it. Monetary savings in terms of 46.32 billion, and power requirement would be 670 watt. If I show you the targets set by other countries, then I go for China, like they support development of EVs, including buses, sanitation trucks, and urban logistic vehicles. So all other countries have set their targets by 2030, but we still need to do a little work on that. Let's say France, 7 billion charging points of EVs and PHEVs across the country. Sweden has done 70% reduction in emission from transport sector. Likewise, Norway, Mexico, India, Finland. India, their Electricity Act of 2003 allowed individuals and corporations to set electric vehicle facilities without a need of prior license. So they are facilitating their country. Here again, you can see the market share of the total vehicular transportation across the various countries. Norway is taking lead, with Norway is taking lead significantly, and they already had clear air compared to the most part of the world. However, they are still concerned about the little pollution that they have. Similar is the case with the comparison with the China, India, and Sri Lanka. We can see that India is really ambitious about this electric vehicle policy. So they have National Electric Mobility Mission Plan, and by 2030 they want to achieve their 1/3 of their targets. Work on rigorous plan has commenced to indigenously develop electric vehicles and its battery. So they are targeting those sectors in which they want to be self-sufficient in making batteries, because lots of cost is incurred on importing these batteries or importing the other parts of it. It's a whole of assembly, so they are also heading towards making their own electric vehicles, so which is a big deal right now. If I show you the contemporary and the projected power demand and capacity that we have in our country in planned for 2025, so by we can see that by 2025, this orange line shows that we have installed capacity. So by 2025 we will have enough of energy that will be required or necessary for to entertain the electric vehicles that we are going to have. And in future we have planned to use multiple energy resources, and by 2025 we will start relying more on hydro energy along with other energy resources. For example, the solar source. Hydro energy is considered here as more prominent compared to the other source by 2025. So we have planned to use multiple resources rather than just relying on one or two energy resource. So in a comparison with the electric vehicle and fossil fuel vehicle that we have right now, this policy says that we are going to this policy is going to provide zero taxes and duty registration compared to the taxes and duty registration on fossil fuel vehicle. We are going to save lots of money on estimated annual maintenance. Cost per kilometer is less than half than the compared to the conventional vehicles. Then the range with the full tank is 200 kilometer. Range might be less, that as we have already talked about it. Price after 200,000 kilometer will be not a very difference with this one with the conventional vehicle. Fuel saved after 200,000 kilometer will be a lot, because it is totally on other sources, not the fossil fuel source. And emission, lots of emission will be saved. By 2025 we will have 10% of all the vehicles on the road will be the electric vehicles. And because it's a slow transition, we started 100% electric vehicles in from 2018 with 0% of electric vehicle on road, but by the end of 2025 we would be able to have 10% of it. Same, we just talked about it, cars, two-wheelers, buses and trucks. We are going to have ultimate target by 2014 we will have 90% of new sales for cars, 90% of new sales for 2 or 3 vehicles, 90% of new sales for trucks and buses. And this is a clipping from a news where we can see that by 2040 20% of small vehicle passenger kilometer will be replaced by electricity and 10% of bus passengers. And by 2040, energy efficiency of all conventional vehicle technology will be improved by 10%. 20% of small vehicle activities will be replaced by large buses and not road mean of transport. And about the level chargings, we will have a different level charging in which we will have level 1 for us, the common users, 10 to 20 hour of charge, and we can install it at our workplaces. Then workplaces and public places, we will be able to charge it for 4 to 8 hours for 19.2 kilowatt of energy. We will have it. And for level 3 charging, it will only be for commercial use. And within 20 to 30 minutes, we will have charge 200 to 500 volt or 50 kilowatt to 120 kilowatt. So by the end of the day, we will have 0.5 million electric vehicles daily on the road. It will give us revenue of 31.5 billion. It will save capacity payment by Pak rupees 21 billion. Net profit achieved will be 52.5 billion, and 4.83 of tetra watt hour we will save it. The recommended policy that government has given us right now is that they have recommended that reduced duty and taxes will be up to 5%. There will be more tax relaxations. 500,000 EVs will be on road by 2025. Smart metering of EV charging stations will take place to encourage charging infrastructure. Public and private sector will have a joint venture, and it will be further promoted. And then installation of charging infrastructure is required in major cities and across major roads. And to maximize the benefit of EVs, a research and development facility will be required. So I conclude my presentation here with these conclusions and take home message for all of us, that there are lots of opportunities for all of us here, from academia, researcher, consultant, businessman. For all of us, we have something to share, to take share in this industry of electric vehicles and make public. But what we need to do now is that we need to make public aware of new technologies, its benefit, because rather than suddenly introducing them into our society, we need to clear their doubts. We need to assess the social impacts of these. We need standardization of technology. Now, for example, we talked about different switches, AC, DC modes of charging, etc. So we need a standardization of technology before implementing this. Then the reduction of unnecessary duplication of investment and of effort. So we need to make a policy where each and every aspect should be minutely and clearly discussed and defined, so that neither we should leave some gray areas nor we should duplicate the efforts and the investment. Think for all modes and not just the cars, because if we'll import buses, electric buses, then we will have more advantage compared to the cars. If we have electric motorbikes, we will have more advantage compared to the cars. More funding and research opportunities are already there, but we need to enhance them. Encourage adoption of EVs, take more risk. As a nation, we need to take more risk, and we need to go for long-term policies and plans. Private sector participation is very important, and we need to invest more in this industry. We need to be self-sufficient in not only having the raw material, but the assembly of the parts, but the repairing of the parts within our own country. We need to have our own experts. We need to have our own plans, that how we are going to launch it, and the infrastructure, how we have to construct it, install it. We need to have our own industry from zero, from head to tail. Need of greater clarity in terms of policies and regulations, and we need to strictly follow up these plans. So with this, I would like to thank you for your patience, and if any questions are there, please let me know. Thank you.
Thank you very much, Dr. Reza. We had 3 questions during the course of the lecture. I think you have answered them, but still I will read the 3 questions. Then if you have anything more to say on it, please go ahead. Let me read all the 3 questions together. Then you can, if you have anything to say, please. It is, the first 2 questions are from Ijaz Ali. He's asking, can this idea of EVs be applied to commercial or freight vehicles? And how much load of passengers or freight these vehicles can carry? His supplementary or a second question is, while keeping in mind the power load shedding issue in our country, is there any chance in future to convert these vehicles to solar vehicles? So these are the first 2 questions. If you want to say something, then once you finish, then I'll ask the third one.
Yes, I will come to the first question first. Yes, you said it very right, that not only just the cars, but we need to shift on, we need to shift not only the passenger, but the fleet on electric vehicle as well. And then we will get the real benefit actually. So yes, we need to shift in there, and how much load it will carry, that I cannot answer right now until unless we do some assessment and feasibility study for that. For example, for this Orange Line train, we thought that this would be the ridership, but we are not achieving even the 75% of that ridership, because we missed many aspects. For example, there were parallel modes of public transport running alongside that. So we need to see different aspects, and then we can see that how much it can benefit us, because we are missing many aspects along the way, as I just said. What was the second question? Sorry, can you remind me again?
While keeping in mind the power load shedding issue in our country, is there any chance to, in future, to convert these vehicles to solar power?
Yeah, well, it depends on the commitment of the government, to be honest. As what they have showed us facts and figures, they are saying that we have lots of capacity, we have lots of power, that if we supply, then we can fulfill the need of the that whatever the electric vehicles will need, we can fulfill the need. In fact, they are saying that we have more supply than the demand. So if the demand is created more and more, they can supply it. So that question can be answered there. But right now, whatever their facts and figures are showing, they are moving more towards the hydraulic power rather than the solar power. And with the solar power, though it is a very good option, but we cannot achieve certain targets until and unless we work on that. It is, for example, relating to the efficiency issue and the speed issues, how much solar cells that we have that can store energy for longer durations, and what will happen when we have like it is lowered in its energy or density, what will happen, that what would be the other source that we can use that. So there are multiple answers to that. Yes, we can, but we need to work more on it. I hope I answered the question.
Before going to the third question, I was wondering that for the solar power vehicles, won't we face, for example, in Pakistan, won't we face the problem during the daytime, you will get the energy from the sun. Then for the night time, you need very efficient batteries for the vehicles to run, which are on the solar power. Otherwise, you will need some dual power setup in the cars. What do you think?
Yes. There are solar storage cells as well that can store, and then we can use that energy at night as well. But as I said, that its efficiency will be affected. It will not give us that range that we are expecting. And if we cannot go to that range, then ultimately it is counted towards the loss in a bit.
Yeah, now we have the last question with me, the third one, not the last. It is from Uzair Akram, and he said, or he asked, preferably in developing countries, is it possible to convert the existing vehicles to EV? I think you have probably answered this question, but if you want to say something, please go ahead.
Actually, compared to the conventional vehicle, for the electric vehicles, we have a single assembly, and every part of that is fixed in it. So if we are able to create that, right now we are not able, we don't have capability of that. So if we are able to do that, then yes, we can just take the structure of the conventional vehicle and fit that assembly in it. Then we can do a little bit of tweaking and amendments, and it is doable. But we still need to do the big thing right now, which we are not capable right now.
Muhammad Walid Faraz, well, ma'am, the way question is asked, I just utter the same words. So he's asking, can we make the body of the vehicle from the solar charging plates?
Yeah, to some extent we can, but we have like challenges on that as well. If you are saying that you will apply solar plates on all over your vehicle, and it is storing energy, and then you can use it, I can say that an electrical engineer will be in a good position to answer that. But right now we can use some part of some plates as a solar energy, but it will not, we can not totally rely on this aspect. We still need a second source for that.
So it's a question answer session. If anybody wants to ask more question, or anybody has a question in mind, please type it, or you can ask it. We still have time. Sohail Raza, would you like to ask some question?
Yes, it's not a question. It's more of an interactive discussion, maybe. Out of my own interest, Dr. Iza, I've been reading on the internet. There's a battery company in the name of Our Next Energy in Michigan, USA, who has developed a new battery named Gemini battery, and it is installed in the Tesla Model S, which is recently introduced. And they claim that in one charge, it will cover 1,419 kilometers. That is some 752 miles. So do you see this as a positive change? Because the main issue was frequent charging or development of infrastructure for charging stations. So do you see the development of such batteries that can take the vehicles to larger distances? They'll be a positive step in making it more popular.
Well, I think yes. Right now, if I want to share with you that I'm collaborating with another colleague on this thing, that when we do frequent charges, then we have lots of energy loss when our energy is converted from, like, say, AC to DC and DC to AC. So it is more beneficial when we charge it for and it will sustain there for many days, and for traveling for the longer distances, then it will be a doable thing, and it will be more beneficial, and it will reduce losses in terms of many aspects. I think it is a good thing. Towards our targets, it's one step ahead of that.
Any more questions? Rizwan Mirza, do you have any question, please? Or any comment?
Nothing in particular, except that she talked about, the speaker talked about 120 volts as a charging source, and the voltage, the other voltage also exceeded the standard supply in Pakistan. Was there any particular reason for this? It was not 220 volts, and it was 10 volts.
Well, this is the problem that I also faced, because they have given this in our policy. So that's why I have commented and recommended as an expert that we should standardization of that. And the reason of this is that because we are importing many stuff. Some things we are importing from one country, and some things we are importing from other country. So that is one of the reasons that is causing this kind of difference. So we need standardization of that.
Dr. Anwar, during your entire discourse, I was thinking about one issue which kept on wongling in my mind, is that, I had a hybrid car, a hybrid SUV, which I was using. And it was giving me a very good efficiency, all was well. But the problem is, whenever I had an issue with that car, it was so difficult to find a good maintenance shop or a good maintenance workshop to repair it. So I think this is going to be one of the impediment which will not help in making these electric vehicles and hybrid cars popular in Pakistan. What is your idea about it?
Yes, I have already said that we need to have experts. We need to have experts. We need to train people to sort out that kind of problem. Yes, this is a problem.
Any more questions? If anybody has, let me check the chat box too. Well, it seems there is no more questions. On behalf of Pakistan Society of Civil Engineers, Dr. Anwar, I thank you very much for presenting such a knowledgeable and exhaustive lecture. We appreciate that, and thank you very much. your shield and your certificate will be delivered to you by Ms. Sadia. She will coordinate with you. That would be delivered either by DHL or by some messenger. I think in the coming week it will be delivered to you. Now, for the audience, they can collect their certificates from 15 February from 83M Model Town Extension, Lahore. And the contact phone number is 0345 424 3404. It is the same 0345 424 3404. So before coming to collect your certificates, you can call this number. It is from 15 February 2022. You can collect your certificates. In the end, again, one more thing. The announcement for the next lecture, it would be on 12th March 2022. Speaker is Dr. Riyad Akhtar Khan, and the topic is rock blasting techniques, case study of Rishon hydropower tunnel. So that is on 12th March 2022. In the end, I would like to thank all the audience who come here, who attend these lectures. They directly, indirectly support Pakistan Society of Civil Engineers in their endeavor to provide young engineers, young and semi-experienced engineers with the knowledgeable lectures so that they can refresh their knowledge and also gain more knowledge. Dr. Saiba, again, thank you very much. And with this, we
Thank you
come
for
to the...
having me over. Thank you. Thank you very much.
You're most welcome, Dr. Saiba. So with this, we come to the conclusion of this webinar, and I will see you on 12th of March, inshallah, with Dr. Riyad Akhtar Khan as our guest speaker. Thank you very much. Allah bless you all.